Hello learners, welcome to this tutorial on practical machine learning using Google Collab. So in the first video, we are going to discuss on the fundamentals of computer vision. I am Satish Kumar, assistant professor from Anna University, and this is my website. You can look for more information from this website, and this is the email which you can contact me. So first let us start with a basic question. What is an image? So image is nothing but an information projected or displayed in a two-dimensional space. So we have information. So this information can be projected in different dimensions. For example, a speech signal is a one-dimension information. So the amplitude of our speech signal varies with respect to time. So here I have a one-dimension space. Whereas if I try to convey an information in a 2D space, we can represent the two dimension in terms of a x or y or a or b, any name we can give to that dimension. Then it is called as an image. So the image is made up of a fundamental element called as pixels. So what is a pixel? So pixels are nothing but the raw building block of an image. So these pixels can be of two types. Either it can be a color pixel or it can be an intensity pixel, depending upon the light information in the pixel. So usually this color or light intensity information will need to be coded in terms of a number so that a computer can understand it in a better way. So in order to do that, we use a grayscale pixel with a coding range from 0 to 255, which means a value of 0 will be considered as a black color and the value of 255 will be represented as a white color. So why do we need to take this range from 0 to 255? Why not we take it from 1 to 1000 or 1 to 100? Because we are going to use a 8-bit CPU. So 8-bit CPU in the sense which can do some 8-bit arithmetic and logical operations. So in order to do that, when I represent it, when I represent the grayscale pixel as an 8-bit number, it will be easy for the computer to do the process. So 8-bit data represents 2 power 8 different combinations of your data is possible. So 2 power 8 is equal to 256. So that is why we use a coding technique from 0 to 255. Another type of pixel is your color pixel. So color pixel, usually it will be represented by 3 fundamental colors: red, green and blue. So this color information also needs to be coded so that it can be understood by your computer. So again, we take a scale, the linear scale. In terms of red color, we take 0 to 255, green color 0 to 255, blue color 0 to 255. So here what does this 0 represent? So the 0 represents absence of a color, whereas 255 represents the purest form of the color. So purest form in the sense it contains only one wavelength. So the color contains only one single wavelength, that we call it as a purest form. As the wavelengths gets added up, then it becomes an impure form of a color. So the 0 represents a purest absence of a color, whereas 255 represents the purest form of a color. So each color R, G and B are coded with a value of 0 to 255. So by mixing these 3 colors R, G and B in different proportions, we can get different shades of colors. So how many such colors we can get? 256 by 256 by 256 number of colors, because red can take a value from 0 to 255, green can take a value from 0 to 255, same way blue can take a value from 0 to 255. So total possible combination is 256 by 256 by 256 colors we can represent using this RGB model. Next, we will discuss about on how to access a pixel in an image. So we use a coordinate system to represent the position of each and every pixel in an image. So here I have shown a sample image of size 8 by 8. So where this column is represented as a width and row is represented as a height. So each column and row are represented by a number, and the number starts with a 0. So first row, first column, the first pixel is having a coordinate of 0, 0. Same way, when I want to access this pixel, which has a width of 3, height of 4, it is represented by 3, 4. Same way, if I want to access this bottom rightmost pixel, in that case, my width is 7, also my height is 7. So it is represented by 7, 7. So the coordinates of each and every pixel is represented in terms of width, height information. Next, we will talk about the models, different models by which we can represent our image. So first, we will discuss about a RGB model. Here I have already discussed. So an image can contain a value in red, green as well as blue. So by combining these three colors, I can get different shades of color. So here you can see that one axis belongs to red, another axis belongs to green, and the third axis belongs to blue. So if I try to see here, at this point red is minimum and green is also minimum, and at this point inside the cube I have blue is also minimum. So red, green and blue are minimum, which means red takes a value of 0, green takes a value of 0 and blue takes a value of 0, which means I don't have any colors. Red, green, blue, we don't have the color, so it will be represented as a black color. Whereas here at this point, the arrow head, it represents the maximum value. So here at this point, if I try to see red as a maximum value, green as a maximum value and blue as a maximum value. So which means this point represents a white color. So red takes a 255, green takes a 255, blue takes a 255. So at this point I have a white color. So by changing the color combination, by changing the values of red, green and blue, we can get different shades of a color. So such a model is called as a RGB model. So one major drawback of this RGB model is we don't have a lightness parameter. So whether my color is a dark color or a light color, that cannot be represented in this RGB model. Whereas in order to do any computer vision task or machine learning task, this intensity value plays a very, very vital role. So for that we go for the second model called as Hsv model. So in Hsv model, we have again 3 dimensions: hue, saturation and value. But now the model is represented in terms of a cylinder. So where the hue takes the circumference of your cylinder, saturation takes the radiation dimension of your cylinder, value takes the height dimension of your cylinder. So here when I see this saturation and value is a linear scale, whereas hue is a circular scale. Hue is a circular scale. So we can use again a coding technique similar to that of RGB for your value and saturation, since it is a linear scale. So I can take 0 to 255 for value. Same way for saturation also we can take 0 to 255. But for hue, since it is on a circular scale, it need to be represented by 360 degrees. So 360 is a number which is larger than your 8-bit value. So 8-bit value maximum we can go up to 255. But 360 is greater than 255. So what we can do is we can project this hue scale onto a 180 degree scale. So thereby I can represent this as a 8-bit number representation. So what we do is we try to map a 360 degree data onto a 180-degree space. So thereby I get how many possible color combinations we can get? We can get 180 by 256 by 256. Colors we can obtain using this Hsv model. So the important thing with here is hue represents the color information, value represents the intensity information, whether the color is a light color or a dark color. Same way saturation represents the purity of the color, whether it is a purest form of a color or an impure form of a color. So impure form in the sense many other wavelengths added with the color wavelength, thereby its purity gets lost. So here as usual, when I see the bottom of your arrowhead, it represents a low value of saturation. The arrowhead indicates the maximum value of your saturation. So here when I see a low value of saturation, it is in a impure form. So impure form in the sense here you can see a white color here. Whereas when I go towards the outer circumference, the purity of a color gets improved. Same way for a value, if I see at the bottom, we have a low value, which means it is a dark color. As I go towards top, the value gets increased to 255. So thereby I get a bright color. Circumference of a hue, we get different shades of a color. So this model, Hsv model, is very helpful for your computer vision and in machine learning tasks. But in order to have a better comparison of two colors, we go with a lab color space model. So this lab color space model represented in terms of a sphere. So lab means L luminous channel, A and B are the color channels. So here you can see the luminous channel is represented by the height of the sphere. One end I have black and another end I have white color. Whereas the color information A and B is along the horizontal axis. So here B, A channel is represented one end by green color, other end by a red color. Same way, perpendicular to it, I have a B channel. One end I have a blue color, other end I have a yellow color. So what is the significance of this lab color space model? We can find the similarity between the two colors easily. So for example, if I take green and red, I want to know whether these two colors are similar or not. Green is on the left side, red is on the right side. So if I try to see the distance between the two colors, it is maximum. If the distance is maximum, then the two colors are dissimilar in nature. So for example, if I take a red and pink, so red is here, pink is around in this position. If I try to take the distance between these two pixels, it will be less. So which means the red and pink are somewhat similar to each other. So this lab model is very well useful to find the similarity between the color content. So this is very helpful when we try to do machine learning algorithms to find whether the object, query object is similar to that of your database object or not. So in those scenarios, we can make use of this lab model to get a better information. So with this fundamentals on an image, now let us move to the Google Collab environment where we try to do the programming and try to learn the fundamental concepts of your computer vision technique. Go to google.com. So in google.com, we can search for Google Collab. So it opens this link, welcome to Collaboratory Google Research. Go to this link. Here, this is the Google Collab page, which is provided for free by Google. So if I want to do much more machine learning algorithms which occupy very much data intensive tasks, in that case you can go for the purchase of this Google Collab. So here, what is the use of this Google Collab is we can write and execute Python programs in a browser. And the main advantages of this Collab is it requires zero configuration, and Google also provides us with the GPU and TPUs free of charge. So we can make use of this cloud-based GPUs and TPUs to do our machine learning and computer vision tasks. And we can also easily share our code with others. So, and they have also provided different examples on how to use this Collab. So you can go through this link and you can see. So how to perform a data science application, how to perform machine learning applications, and resources with lot of examples have also been provided by Google Collab. So the important thing to note here is you need to have a Gmail account to access your Google Collab environment. So once you created your Gmail account, you can sign in using the Gmail account. Once I signed in, it takes me to the Google Drive, and I can take the program which is stored in your Google Drive. So I have already created a program and it is named as basic load image.ipynb. So this is the format of your Jupyter notebook, which is an interactive platform to learn machine learning Python programs. So let me open that program. So it opens the program. So here you can see this is the program which I will be explaining in this tutorial. So here I have two important things. One is I can have a space to put my text so that it becomes easy for me to explain the concepts. And there is another space called as a cell where I can put the code information, and the code can be run cell by cell. So I can execute this cell and I can see whether the code available in this section it's working properly or not. So like that we can be able to see cell by cell execution output. So that will be easy for us to debug our program, and to make a new program also it will be very helpful because we can go by step creation. So the first thing which we need to do here when we enter into the Google Collab, we need to go and make use of a cloud-based CPU, a GPU or TPUs. So in order to do that, what you can do is you can go to this edit function, and in that you have notebook settings. So in notebook settings, when you click on it, here you can see there is a hardware accelerator. So here you have an option of none. None means you will be making use of a CPU, local system CPU, or you can use a GPU or TPUs. You can use it for your program. So for this program, I am going to use a GPU. So I am going to select the GPU and press save. So once that is done, now the GPU we have selected for executing our program. Now we need to get connected to that GPU, cloud-based GPU. So in order to do that, go to the right side, you have a connect option. So when I press this connect, it will get connected to the cloud-based GPU. So now it shows connecting. Very soon it will be connected to your cloud-based GPU. So it gets initialized and now it is connected. So now we can execute our code in the cloud-based GPU. So in the first program, what we are going to do is we are going to do certain tasks like reading an image from your drive. So I am going to take an image which is already stored in my Google Drive. I am going to try to take that image and see the characteristics of the image. So characteristics in the sense, what is the width information, what is the height information, whether it is a color image or a black and white image. So such type of characteristics we try to see from the image. Then in any image processing task or computer vision task, we will be doing some processing on a pixel. We will try to modify the image content. Once that is done, we need to know how to save this image back onto your drive. So for that I will be showing on how to save an image to your drive. Then the fourth objective will be how to access and modify a pixel in an image. So not only pixel information, we can also access the RGB channels. So RGB are the fundamental colors of your image. Each pixel will be represented by RGB value. So as a whole, for an image, we have three matrices: red matrix, green matrix, and blue matrix. So that we call it as a channels. So we can access this red matrix, green matrix, and blue matrix. And how to do that, let me try to explain in this program. Then, as a next objective, we can combine these three matrices. If I have separate red matrix, green matrix, and blue matrix, I can combine this information to form a RGB information, which is nothing but your color image. And the seventh objective which we are going to discuss is on color space conversion. How to convert from one color model to another color model. So in my explanation, I have talked about three color models, which is RGB, Hsv, and lab color space model. So like that, we have many such color space model like CMYK, YCBCR. So each model has its own advantages as well as disadvantages. So here I will try to show you few conversions from RGB to Hsv, RGB to lab color space, and RGB to grayscale images. Then I will talk about on how to split and access a particular section in an image. If I want to extract some region alone, then I should know how to access a particular region in an image using the coordinate system and how to do some modification on that selected region. So such things will be discussed in this 8th objective. So finally, we will conclude the program by computing the histogram representation of our image. So what do you mean by an histogram? So histogram gives an information on the distribution of color content in an image. Which color is more in the image? Which color is less in the image? So such type of information can be obtained using the histogram computation. Again, in histogram computation, we have two things. One is grayscale histogram and color histogram. In grayscale histogram, the grayscale values will be represented. Which grayscale value is dominant in an image and which grayscale value is minimum in an image. Same way, color histograms, we can draw a histogram for red color, green color, and blue color, and using that information, we can find which color as dominant in our image. So these are the 9 objectives for which we are going to do our first program. Let me zoom in this window so that it looks better. So in the first cell, what I have done is I try to import all the supporting packages which I require for the execution of the program. So here all the necessary packages have been called. So from Google Collab patches, I am going to use a function called as cv2.imshow. So where this cv2 represents computer vision version 2. To do computer vision tasks, we require lot of functions. So those functions are available in this cv2 package. So in that one function is imshow. Imshow represents image show. How the image looks like. After reading an image, how the image looks like. That I can visualize using this cv2_imshow. Then in a Python environment, we don't have a plotting tool. So we make use of a plotting tool from a third party. So we get the package from matplotlib.pyplot. In short form, we use it as PLT. So matplotlib is provided by MathWorks and it is provided as an open source. In that I have a Python plot. And in order to use it, instead of using this big name, I can use in short form as a PLT in our program. So that I try to import into our code. Next thing is I am going to use and argument parse. So usually in any machine learning or in any computer vision task, either I can process individual images or I can process a collection of images as a data set. If I want to do a collection of images processing, then in that case I need not open my code each and every time to give the image and do the processing and save it. What I can do is I can give the folder itself. So this folder data can be read by your code automatically, and during the runtime I can give this information. So for that we make use of this argument parse library. So while executing a code, I will specify the location of our data, folder location. So thereby the code will go to that location, pick the first image, do processing, then go to the second image, do the processing. So it will be much more easier to do the task. So for that we make use of this argument parse library. Then the next package which we are going to use is CV2 package, computer vision version 2. So here it contains lot of image processing functions are available. We can make use of those functions in our program. Next thing is I am going to import Numpy. So Numpy is a numerical Python library, so which is used mainly for doing your array and matrix computations. So in order to do that, we use in short form NP in our program. Since images are two-dimensional information, it can be processed using matrices or as an arrays. So these are the packages which we are going to import in our program. So let me run this section to see any error is there. So I can just press this play button to do the execution of the task. So here it shows tick mark, which means I don't have any errors. If any errors are there, it will be indicated below this cell. Next, we are going to take an image from the hard disk. So for that, I am going to use again google.collab package. In that, I am going to use a function called as files. So using these files, I am trying to upload that information to the Google Collab environment. So it goes into the variable uploaded. So let me execute this. Then you can see it is asking to choose a file. So let me go and choose a file where it is located. So I have it in my Google Drive. So I go to Google Drive. I select the image. So I have it in my image folder. In that I have two images. So let me take this APJ Abdul Kalam image. Open. So now it gets uploaded. You can see a tick mark here, which means it got uploaded into the Google Collab environment. Next, after uploading, we want to see how the image looks like. So for that, I am going to make use of this cv2.imread function. So cv2 is a computer vision version 2 package. In that I have a function called as imread. Imread is image read. So in that I give a name apj.jpg. So which means I am going to read this image and it goes into the variable img. So once I have read this image, I want to see it, how it looks like. So for that I use this function cv2_imshow. Whatever read image is being displayed here. So when I press this, you can see now the cell gets executed and it shows this is the image. After doing this, I want to see the characteristics of this image. For knowing the characteristics, I am going to use the Numpy function. So Numpy has a function called as dot shape. So the characteristics of an image will be represented as a one-dimension array. So usually in the one-dimension array, 0th index will have height information, first index will have width information, and the second index will have the channel information. So channel means whether it is a color channel or a grayscale channel. So color channel means it will be indicated by 3. If it is a grayscale image, it will be indicated by 1. So this information can be obtained using the Numpy function. So I make use of the print statement. So I specify the height and the value will be embedded within this parenthesis. And what value should be embedded within the parenthesis? Dot format of image dot shape of 0. So image is our red image. And for this red image, I am going to take the 0th content of my one dimension matrix. So as I said earlier, in the one dimension, 0th location will have the height information. First position will have the width information. Second position will have the channel information. So that I try to execute and see. So then it shows height of 168 pixels, width of 300 pixels, and channel is 3 since it is a color image. So this will be the width information, this will be the height information. So the characteristics we have seen. Then the next task which we are going to do is, after doing some processing on an image, I need to save the image back to my hard disk or to a Google Drive. So how we can do it? We can just put cv2.imwrite. imwrite stands for image write. I give a new name. You can also specify different formats like apj.png or TIFF format so that it gets automatically converted. So I can change the file name and also I can change the format of the image. So once I execute this, it will get saved in a new name apj_new.jpg. Then the next objective is to access a particular pixel. So for example, here I am going to access a pixel which is at 10,200. In 10,200, I am going to access a pixel. So in the image, I am going to take 10,200. So it will give me 3 values, one for red, green and blue. So remember here, in Python environment, the first value to come out will be from 0 index. Next will be from 1 and next will be from 2, and it goes on like that. So usually the color information of each and every pixel will be saved in a one dimension array. So red will be in index 2, green will be in index 1, blue will be in index 0. So while reading the pixel value, the first value to get is your blue color. Next will be your green color, next will be your red color. So index 0 will come first, index 1 will come second, index 2 will come third. So this is the order in which we try to read the pixel value. So once I read this value, I want to print it and see what is the value of that pixel. So print pixel at 10,200 as what is the red color. So here I give some variable. So this variable will be mapped with the red pixel values. Same way green, blue. So here you can see dot format. So whatever I have defined here red, it is mapped with R. Green is mapped with G. And blue is mapped with B. So like that we try to map it and see. So then what I am going to do? I am going to change that pixel value. So let me change that pixel value to some other color. So in order to do that, here I define the color information. So here let me change it to some 0, 255, which means the first value will be blue color, second value will be green color, third value will be red color. So here I say I don't have a blue color, I don't have a green color, but red color is the purest form of a red color. So this color information I am going to put it onto this coordinate, image of 10,200. So once I have done that, again I try to read it and see whether it has changed or not. So for that again I use image 10,200, then print that value. Pixel at 10,200, the same red, green and blue is mapped with your red BGR. Then finally I try to show the image whether it is having that red color pixel or not, we try to visualize. When I execute this cell, You can see here. So this is the location. You can see there is a red dot here. So in this position, this I have 10 height and 200 is my width. So here in this location, you can see a red dot appearing here. And you can also see those information while printing the statement. First, initially the value in that region is red is 245, green is 173, blue is 9. So after modifying it, you can see that red has changed to 255, green is 0, blue is 0, and you can also visualize the red dot here. Okay. Next, we are going to discuss on how to see the individual matrices. So earlier we discussed about on how to access a pixel value. So now we will see the image contains many pixels, and these pixels can be represented as a matrix. Red matrix, green matrix, and blue matrix. So how to look at those information? So for that we make use of a function available in your computer vision version 2, that is hsv2.split function. So it will split your image into 3 different matrices, one for blue, one for green, and one for red. So we get a blue matrix, green matrix, and a red matrix. So once I get this information, let me print and see how it looks like. So print red, and we try to display it using hsv2.imshow. Same way for green, same way for blue. When I execute this, you can see this is the red information, this is the green information, and this is the blue information. So why it looks grayscale images? Because here we are displaying only one matrix. So one matrix means it will be nothing but a grayscale image. So what we can understand from this image? So if you look at this red matrix, so here I have few regions where it represented as a white color. So white color means it is, I have red purest form 255. In red matrix 255, when it is represented as a grayscale image, it will be white color. So you can see I have purest form of red colors in this region. Whereas if I have black color, which means I don't have red color content here, 0. 0 represents we don't have a red color content. So those regions will appear as a black. So by plotting it as a grayscale image, we can easily understand, okay, what is the color information. Same way when I go for green, if I see here, I have in the middle part, I have some white pixels, which means I have purest form of green color in the center region. I have few black regions, which indicates I have no green pixels at all in the image in that region. So thereby I can easily understand how the content gets in your image. Green color content. Same way for blue color content. So you can see, so blue information is very low in our image. So that is why we can have more black regions in the image. Next, if I have 3 different matrices, red, green, and blue, whether I can combine these 3 matrices to form a color image? Yes, we can do it. So for that we can make use of this function called as hsv2.merge. So hsv2.merge will combine your blue matrix, green matrix, and red matrix to form a color image. So when I execute this, you can see a color image is formed using the 3 matrix. So hsv2.split function will separate out the matrix, whereas hsv2.merge function will combine the matrix. Next thing which we are going to do is, we try to extract a region from an image. Or before that, we will try to visualize this red matrix and green matrix and blue matrix in the color itself. Let me see the red matrix in red color, green matrix in green color, and blue matrix in blue color. So in order to do that, we use np.zeros function. So np is a numerical Python library which is mainly used for array and matrix computation, and we are going to create a zero matrix. So zero matrix with a dimension of colon 2. Colon 2 indicates 0, 1. So 0 is your height information, 1 is your width information. So depending upon width and height of the image, I am going to create a zero matrix. So if the matrix contains 0, which means it is a black image. Once I created a zero matrix, I am going to use this zero matrix to represent the red, green and blue. So what I am going to do, I am going to combine the three matrices, zero matrix and red matrix, which means blue is a zero matrix, green is a zero matrix, and we take a red matrix. So we combine, we merge it to show the red matrix in terms of a red color. Same thing we do it for green and blue matrix. So here blue, I take it as a zero matrix, green matrix as it is, and blue zero matrix. Red zero matrix. Same way I combine a blue matrix with zero matrix of green and red. When I execute this, you can visualize that red matrix as red color and green matrix as green color and blue matrix as blue color. Next thing which we are going to do is on converting the color information to other space models. So first we are going to convert your color from BGR to grayscale information. So BGR is a 3 matrix, whereas grayscale is a single matrix. So we are going to convert from 3 matrix to a single matrix. So the grayscale will be in terms of a black and white color. So in order to do that, I have a function called as cv2.convertColor. So cv2.convertColor, I give the image and from which format to which format we need to convert. So that is specified by this flag. cv2.color BGR to grayscale image. So after conversion, I am going to display how the original information is and how the converted image is going to be there. So when I press this, you can see this is our original image, color image, and this is the converted image, which is a grayscale image. Similarly, we can convert to other color formats also, Hsv model and lab color space model. So that is what we are going to do next. Here you can see, again I use the same function, cv2.convertColor. Now I use a different flag, cv2.color underscore BGR to Hsv. So RGB channels will be converted into H, S and V channels. Then try to plot it and see how these channels look like. Since this Hsv is not an additive model, whereas RGB is an additive model. If I mix 3 RGB color content, I will get a new color. Whereas Hsv is a cylindrical model. Here, by adding the values, I will not get a new color. So you will find the Hsv images will be somewhat different. So here I use a for loop to get the H information separately, S information separately and V information separately, and try to plot individually each channels using the for loop. You can see this is your Hsv together. Since this is not an additive, you see the image is not the exact original image. And you can see this is the H information, S information and V information. Same way we can convert the RGB model to a lab color space model. So again, only the flag alone changes, BGR to lab color space. Again I display all the colors together, and also individually we try to display the L channel, A channel and B channel. And again this lab color space model is also a spherical model. So adding the 3 color content will not produce the original color information. So when I execute this, you can look at it. This is the lab color space model information when we add the L, A and B matrices, and individually it looks like L, A and B channels. Next, we will discuss about on how to extract a region from an image. So for that, first we are going to take the characteristics of the image by using the shape function. Image.shape colon 2 indicates I am going to take 0 and 1. So 0 represents height information, 1 represents width information. So it goes to variable h and w. So height information goes to h, width information goes to w. So I try to plot the image and see original image. Now I want to find the center point of the image. To do that, I use integer of w by 2 and integer of h by 2. So usually this w by 2 and h by 2 will be a real number. So in order to make it much more easier for computation, I converted it into an integer data. So thereby I get the center of x and center of y. So x indicates the width information, y indicates the height information. So I get the center of x, center of width, same way center of y is nothing but center of your height information. So this gives the center point of my image. So now I am going to split the image into 4 segments based upon this center value. How to do it? So first I take the top left region. So top left region is specified by image of 0 to cy. Cy is height by 2, h by 2, right? Cy is h by 2. So I am going to take from 0. So for example, here if I take this image, this is 0 and this is w. Same way this is 0, this point is your h. So I take 0 to h by 2. So 0 to h by 2 will be somewhere here between. Same way I take 0 to cx. So 0 to w by 2. So it will be here. So only this top left region will be extracted and it will be saved in the TL variable. Same way for top right what we have to do again 0 to h by 2 and now from w by 2 to w, that gives the top right information. So my height will be 0 to h by 2, my width will be w by 2 to w, that gives the width information. So I take 0 to h by 2 and w by 2 to w, that gives the top right. Same way I can extract bottom left and bottom right corners also. Then I try to plot it and see using imshow function. When I run this code, you can visualize this is my original image. Then we have segmented our image, top left, top right, bottom left and bottom right. So we have segmented our image into 4 quadrants. Next, I want to modify a particular region alone in the image. After segmenting it, I want to modify it. So for that what we do, I take the segment which is 0 to cy. 0 to cy means 0 to h by 2. Same as 0 to cx means 0 to w by 2. So which is your top left region. This indicates top left region and I want to fill it with some white color. So in order to do that, I give B value as 255, green value as 255 and red value as 255. So by mixing the purest form of red, green and blue, I get a white color. So when I execute this, you can see the top left region alone is replaced by white pixels. Other regions, it looks as it is. Next, the final objective which we are going to do is we are going to compute the histogram for the image. So as I said, histogram is nothing but the information on the color distribution or grayscale value distribution. which color is dominant in our image, which grayscale is dominant in our image, so that we can represent using a histogram. So here, to do that, first thing is, let us do two ways. One is we try to compute the grayscale histogram, and also we try to compute the color histogram. So how to do that? So first thing is, in order to do grayscale histogram, I am going to convert it. Color conversion from BGR to grayscale. I have a grayscale image in this variable. So now I want to compute the histogram for this grayscale image. So how to do it? I use a function called as cv2.calculate histogram. So I give the image and we are going to compute the histogram for only one channel. So I specify 0. If it is for 3 channels, we have to give 0, 1 and 2. Then the next variable defines a mask. Mask in the sense, I can select a region in an image, and for that region alone I can compute the histogram. That is nothing but creating a mask and trying to produce a histogram in that masked region. So right now for this example, I am not going to use any mask, so I specify it as none. So mask, we will look at it in much detail when we go to the further tutorials. Then, how many grayscales we are going to take? We are going to take 256 grayscales. So 256 indicates the gray levels will start from 0 to 255. So altogether I will have 256 gray levels. So usually in a Python, when I specify 256, which means it will be indexed from 0 and it will end at 255. Remember, 256 will not be included in your computation. So this gives the number of grayscales which we are going to use. And next parameter is your range of values goes into each of the bin. So I can take a certain pixel values alone, certain grayscale values alone, and I can put it onto this bins. Here what we do is, I am going to take the entire, my pixel, grayscale pixel is going to vary from 0 to 255. So I am going to take all the values of grayscale and I am trying to put it onto this bins. So for that I use this 0 to 256. Again remember, even though I specify 256, in Python, since it is a 0 indexed, it will count till 255. 256 will not be included in the computation. So we try to plot it and see. So let me explain once again this histogram function. cv2.calculate histogram. I give the grayscale image and we are going to compute the histogram for only one matrix. So we specify it as 0. And we are not going to use any mask. So mask is none. And how many bins we are going to have in our histogram? 256 bins, which means one bin for each grayscale. So 0 will have one bin, 1 will have another bin, so like that it goes until 255 grayscale will have another bin. And what should be the range of values to go into this bin? Is 0 to 255 is specified here. So when I execute this, we use Matlab functions like figure, title, bins. So here I specify x limit and y limit to specify the axis limit. In x limit, I go from 0 to 256. 256 means it goes from 0 to 255. It represents the bins. X axis represents the bins. In y axis, we represent the grayscale values or number of grayscale values in the image. So I am going to limit it to 0 to 1999. Remember, 2000 will not be included in your computation. When I look at it, you can see this is the grayscale histogram. Along x-axis, I have the bins. So bins represent the grayscale values from 0 to 255. And the y-axis represents the number of pixels for each and every gray level. So if I get a plot like this, which indicates, you can see around 255, I have a very large value, which means in my image, I have lot of white pixels are there. And I have few pixels in the value range of 150 to 250. Same way, I have a large number of pixels in the range of some 25 to 175. In that region, I have lot of pixels. So like that, we can understand an image through the histogram. So which pixel is more in our image? Which pixel is dominant in our image? So such information can be obtained. Next is, here instead of putting our y-axis on a large scale, I can normalize this y-axis to be within a value of 1. So normalization can be done. So in order to do normalization, we use this function histogram slash equal to, means I take each grayscale value divided by the total number of pixel contents. For example, here I have in gray level, so let us assume I have in 75 gray level, I have some 500 pixels. So what I do is 500 divided by total number of pixels. That will give me the normalized value at this point. Same way we try to do it for all the bins. So thereby I get a normalized histogram. Once I get normalized histogram, I try to plot it and see. So when I plot it and see, now you can see you will get the same information. You will get the same information. Only one difference is now the y scale is normalized. So normalized to take a value between 0 to 1. So here I have plotted only till 0.05. And next, what we are going to do is, we are going to compute the color histogram. For computing the color histogram, we are going to split the image to separate it out as a R, G and B matrices. Then for each matrix, we are going to compute the histogram. So that we are going to do it using the for statement. So here I am going to take one by one the channel and I am going to compute the histogram here. So it is same. So channel, so we are going to compute the histogram for only one channel. So we have specified it as 0. And we are not going to use a mask. And how many bins per channel? 256 bins. And what is the range of values? Will be 0 to 256, which means 0 to 255. And plot that value. Again, when the for loop runs for the second time, we compute the histogram for next channel and put it onto the same image. Again, when the for loop runs for the third time, it will compute the histogram for the subsequent channel and it will try to put it onto the same window. When I plot it, you can see here all the three histograms. So red color graph indicates the histogram for your red matrix. Green color curve indicates the histogram for your green matrix. Same way blue color curve indicates the histogram for your blue matrix. So from this you can see again in the 255 region I have more number of red, green and blue pixels, which means lot of white pixels are there in the image that we can able to understand. So we can also normalize this y-axis intensity as we have done earlier for the grayscale image. That I will leave it to you for your practice. So in this tutorial, we have discussed quite a few number of fundamental aspects like how to read an image from a hard disk or through a Google Drive, how to see the characteristics of the image, what will be the width information, height information and channel information, how to save it back to your drive, how to access and modify a pixel, how to access the individual channels, red matrix, green matrix and blue matrix. If I have three separate matrices, how to combine these three matrices to form a color information, how to convert from one color space to another color space, from RGB to Hsv, RGB to Lab and RGB to Grayscale, how to split and access a particular region in an image, and finally we discussed about how to represent a grayscale histogram and a color histogram. Thanks for watching. Please subscribe for more technical learning. Thank you.